Hello. Today we are going to find the watershed delineation using DEM, digital elevation model, in long version, and uh, we will find them using QGIS application, and its version is 3.16. Because I choose this one because it is the most stable version of it. Otherwise, our functions do not work properly, and it mixes the coordinates of this project. So I choose 3.16 of QGIS. First, we need to install some plugins, and I can show you. We need quick map services for downloading Google Maps, and we will use the Google hybrid version. And also we need SRTM downloader, and SRTM will get the data from the NASA's database. Profile tool, in this case we are not gonna need that, so I can switch it off, and maybe it turned on, but I won't use this also. So first we need to add a layer from Google Hybrid. So I use from the vector toolbar. I use Quick Map Services plugin, and from that I add Google Hybrid. So as you can see, we have a world map, and in our work package 2 we are working on the city Konya, and more specifically we are working on Altınapa Dam, and in our project we need to supply water from Altınapa Dam to the district of Meram, which is somewhere here. So why do we need them? I mean the digital elevation model, not the DEM, the structure. We use digital elevation models to store elevation data by every pixel of it. So we currently do not use contour maps, which are still in use in highway engineering. Maybe in some of my class we use this, but in this lecture we need to use the DEM. So we have the Google hybrid map, and we need to download the SRTM map, which is a map obtained from the satellites, and it shows the topographical properties. So if I click this icon, SRTM downloader, which is also a plugin you should install before using that, we need to zoom our water resource. So we are our water resource is Altınapa Dam, so I zoom in around it, and I think it's enough. and we need to download just this part. So I click set canvas extend. So it indicates a coordinates. Indicates the coordinates of the middle point, I guess. So if I click download, it just downloads, and you should also in addition, I forgot to mention, you need to be registered from earthdata.nasa.gov, because our data is obtained from there. So in order to download this data, you need to be signed up. So if I click OK, and it will download this map. So why do we use set canvas extend? Because it downloads the nearest map of this area. Otherwise, if I zoomed out, as you can see, if I click SRTM downloader and set canvas extend, and finally if I download it, it will bring all these maps of this area. So it will be a harder task to complete, and it will also maybe slow down my computer. So after that, we need to change the coordinate system, because as you can see, this coordinate system is slightly wrong in fact, because of the shape of our planet. We need some small adjustments. So I changed the coordinate reference system to 36 north, because as you can see, my project is inside of this UTM zone 36, and so I choose this one, apply and OK. So this map is tilted a little bit, but maybe you cannot see, but I know it is tilted. So, and also now I changed the coordinate system of the Google hybrid map, but also I need to change this. This also. So layer CRS and set to another coordinate reference system. I use 32636. So I need to match that again. So it vanishes because I need to warp this layer again. So I came projections and warp reproject. So target CRS would be 36 north. So if I press run, it will bring back, and maybe you can see that this time this layer is tilted again. So this version of layer is more precise than the older one. So the next step I will gonna do is field sinks, but I will use the Wang Lui version. So I choose reprojected because as you can see, if I hide this layer, and you cannot see this layer also, so I will use reprojected. So fill things wrongly, reprojected, fill them, maybe yes, you can, we don't need these two. So if I press OK, that will give me the filled them. These processes may take a little while if I wait that. These errors can be neglected. They are not so sorry. Why this error? I don't know. If I try that again, if that happens again, I will pause the video. No, okay, fill them is here. So we have the layer digital elevation model. We filled them the things because otherwise upslope area function will not work at the end. So, and after that we will use Strahler order. This Strahler order will give me the veins of our river, and at the end we have all the river that surrounds our Altanapa Dam, or this layer of dam also. So as you can see, we can see all the river's veins and all the other water connections. So as summary, we need to have this basin's river. So we should cut these and define a basin for it. So in Strahler order, we need to copy the coordinate of it. So if I zoom in, if I came close to the dam, and this is the outlet of the dam, so if I copy the coordinate and I use this one because I changed the coordinate system, so I copy, and if I save it in a notepad, that is like that. So after that we can go to the upslope area. So elevation section, we need to choose them because it stores the elevation data in them, not the Strahler order. Strahler order will give the connections of the river. So I choose them for that. And in X coordinate, I copy that. And Y coordinates, I copy that. And in case of our method, we use deterministic 8. And if I run, this again may also take a little while. Yes, as you can see, we have determined a basin of our river, and what it means. I can say that if uh, if a precipitation or rain drops inside this area, finally uh, at some time, this water droplet will eventually travel through the main channel of the river. So if a water droplet if water drops here, um, at the end eventually the water travels go through all this uh, distance and go in Altanapa Dam. So we have obtained the basin of this river. So I need to do some editing. So um, I want to click polygonize because I want to do some editing on it. So I choose absolute area and I run. As you can see, it vectorized all this area, so I don't need that right now. So if I click the vectorize and toggle editing, I can edit this map. So if I open up attribute table, as you can see, if I select one of them, the yellow area is selected. The yellow area means it is selected. So if I delete here, this will give me the basin of river. This will just give me the basin of river. So and also I can edit and outline it as blue outline. So as you can see, the basin more clear, I think. Even with the naked eye, you can see the main river of this basin, and at the end, the water stored here in Altanapa Dam. So now I need to close the toggle editing. Yes, I want to save that. And also, again, I need the watershed delineation of this basin. So we need to crop. We need to crop this Strahler order, and the other Strahler order river connections are not necessary, so I need to crop this. So I will go to extraction and clip raster by mask layer. So as an input layer, I select Strahler order, and mask layer will be vectorized. Target CRS means coordinate reference system, so I choose UTM zone 36 north as I changed in the beginning. So if I run, as you can see, finally I obtained Strahler order of our basin. So you can see all the river which is located inside of my basin. And this video is finished, I think. Thank you for listening me.